And we're going to focus on the bump map. We're going to start out by creating a noise node for this and attach our bump. Decrease the scale. We could take a look at that. But let's say we wanted to have our scale based on altitude or slope. We could easily connect that parameter. So let's do it on altitude first. We're going to take our scale value and just directly attach that. And now because the way the object is oriented, we get a very undesired result for pretty much maybe what you were expecting. So there is a few things we can do to correct that. And if I select our line and our link between the scale and the altitude, we take a look at that overall gradient. It doesn't look very good. So what we can do is add in a filter node and change that to an absolute value. And now we can see that start to reflect itself on the bottom. But we still have a very large variation between the largest value on top and, of course, the smallest on the bottom, where it's extremely tight. So we could either add another filter to the top or to the bottom. We'll go ahead and just click on that filter again with that selected, which will automatically add that new filter above it. We'll go to a standard filter. We can move that down. And now we can see that start to change in the overall blend. And a little bit more variation. But overall, maybe not as much control as you would like. So I can take this filter, change it to brightness and contrast, and now we can adjust some of these values a little bit more. Maybe reduce our contrast down to a -1, and we could raise our brightness up to 1. And I'm going to go ahead and connect this to our slope instead of our altitude. And we can see that showing up a little bit better, where it's nice and small on the top and then slowly gets larger towards the bottom. We could also reverse that if we want a different type of effect, where we want it to be larger on top and smaller on the bottom. So we'll select that link, our last link, and we want to go underneath all of our settings that we already have in our other two filters. Add a new filter and set that to opposite X. And in this case, that's actually modified it to a point where it doesn't really look correct. So what we can do is change this to something a little bit different. We'll go ahead and delete that. We could add in a math node and change that to invert. And now we see the opposite of an effect. And then we would need to possibly change some of these values in order to get it to look a little bit different, have a little more variation, and more control over that specific effect. We could also use other math nodes as well to modify the way it's going to look. We could use multiply and change the multiply value, and now you can see how we're moving through that gradient, bringing it up towards the top and adjusting that overall blend between the white and the black values. We could change that to a sine wave, and what that'll end up doing is creating that line once again on the bottom. And if we change that to input in degrees, then we have a very uniform surface by using that specific math node. And you can see with a lot of these different math nodes, you're going to get some varied results. But that's mainly because we're using the scale function. We could also do some vector operations using the decomposers. But overall, because with the scale, it's not really going to give us a very good result. We could always change that back to that altitude then, get rid of the absolute, and now we're going to see we have those lines back in there again. So it really depends on what it is you're working with. And let's just change this over to something a little bit different. I'm going to use the bump again just because that shows up really well. We can select that bump output node, add in a fractal node. I'm going to adjust our wavelength down to 0.1 for this fractal. And this is going to be our larger fractal, kind of covering some of the larger parts of the surface, some bigger definition. Increase our roughness just a little. And we're going to create another fractal. And we're just using simple fractals right now. And we'll go into covering some of the other ones just after we take a look at this. I'm going to bring our wavelength down a little bit further, going down to 0.05. Increase that roughness. And now we're not seeing that effect because our connection is on our other fractal. So we can move that over, decrease our gain a little, and I'm also going to decrease that wavelength a little bit more, replacing our 5s with 2s so that we have 0.02 all the way across. So now we have two different types of fractals, one that's a little bit smaller, tighter variations, and then one with larger. So we can delete that link to our bump. We're going to add in a blender node, or our combiner node set to blender, reconnect these inputs, and just as we did with the color before, we're going to adjust our ratio based on slope, but this time we're using two different types of fractals to define our overall definition of the bump. We could also set that to the altitude. And when we do that, we're going to need to add in another filter node in order to modify that gradient. So we can change that to a regular filter and go ahead and bring down that right side just to adjust our blend. And really, depending on the size of the object, depends on where you need to adjust that filter. And if we want to change that just a little bit more, so it looks a little bit different, I'm going to take our second input, which is the more of the tighter grain, and add in a turbulence node to that, using the advanced turbulence so that we have the vortices, and connect that to the origin, and then we'll be able to see a little bit of twisting, increase the amplitude of that so we can see it a little bit better. And now we can see all of that twisting showing up in the top of our surface. And then just that standard simple fractal that we had that really haven't edited too much on the bottom. And this is based on our altitude, of course. And we could also connect that to our slope or our orientation. So depending on where the object is facing, and also over time. Now in this case, we wouldn't really need to connect this to time, mainly because if we wanted to achieve an effect where it was just changing that bump as we move through the surface, that's typically something we could do with keyframe animation, and we wouldn't necessarily need to set up a function for that, although the option is entirely available just by connecting that. And if we delete our filter, we can see this based on our slope. And we could even set up a similar function based on color now to replicate what we currently have for the bump. And what I could easily do is just move this off to the side, kind of rearrange our nodes a little. We're going to go to our color. First add in a combiner, because we want to be using multiple colors for this to match in with each of our simple fractals that we have set up. And we're going to add in 2 color maps, selecting our color output for both of them, and I'm going to load in just a couple of different maps. We use the green purple on our second input, and our first input we can just select pretty much anything. I want something a little different in color, so we're going to use the red, brown, yellow. And now I want to attach our first input to the first input of our other fractal, and do the same with our second. And that way we have 2 different color variations. But right now it's being blended equally, so we want to blend this the same way as we did with the other one by attaching it to our slope. And now these colors are a little bit too similar, so we don't get to see that overall effect too much. So I'm going to load in the foliage, which is going to be green. And now we can see we have the green on the top with the turbulence, and then the other one is more of that red, rockier surface. We can click OK and take a look at that on our terrain. And I'm going to zoom in, move our camera over it just a little bit more, and we can render that out. And we can see, although it's not a very realistic looking surface, it is very interesting. It should give you a very good idea on how these different attributes work. One thing I do want to do is scale this down, which is not going to modify the slope range that we have for the distribution of color or the bump, but reduce the overall scale of each of those individual textures, but it will still be distributed the same. So we can take a look at a render for that once this finishes up. And we can see a little bit more detail. Overall, some of the surfaces might be a little bit too large, but it does look pretty good. Let's take a look at creating the same sort of effect with an image map, so you can see something a little bit more realistic. We're going to go back into that function, and I'm just going to delete the whole thing. We'll start from scratch. It'll be a little bit easier. Go ahead and zoom in. And we're going to start out by adding in a texture map node, and we're going to use a projected texture map, and that way we have our mapping mode set up directly within that. Typically, I only use the projected texture maps just because they are really an improvement on the standard texture maps, and you don't have to worry about the UV coordinates that are set up for it, and it just ends up being a lot easier. Plus, with the addition of the MIP mapping function, it's really a lot more powerful. And most of the time, I just use the projected texture maps and don't even worry about regular ones, although they are there, obviously, so that you can use them. But sometimes you really just don't need them. So we're going to do 2 different texture maps. I'm going to start out by adding in that blender, connect it to our color, and we'll be connecting the bump to this as well. We're going to connect our first input to the color output. And you can also see that we don't have any connection to the position or anything else on the top, and that's because we don't need to define any sort of positioning based on some of the attributes that we normally would for a fractal node or for a noise node or any of the other nodes that are similar to that. As you can see, it basically cuts off at the top, and we really don't need to connect that to any of the input nodes. And add in another projected texture map, and we'll just connect that. So now all we need to do is load in 2 different maps, and we can do that either by double-clicking or clicking on the arrow to load in that specific map. And I'm going to be using part of the Seamless Rock collection again, and I'll include some of these textures within the tutorial so that you can use them. And if you own the collection, then you'll be able to see how to use it a little bit more and really the overall versatility of it. So I'm going to use that Rock 27 part of the collection. And because these specific textures are not square, I just need to adjust the scale on our x-axis just to go to 1.2, and that way I'll stretch it out just a little bit more and make it uniform so that it's actually in position with the way the actual texture is set up. And we're also going to load in that second one. I'll do something a little bit different, the Rock 14. A little bit of a different color and definitely a lot more variation, a much different type of rock. And we might need to play around with the mapping modes in order to get it to look correct. Right now we can see it on the sphere. It looks really good, but it might not look as good on the terrain looking directly down. So we might need to change this mapping mode to faces, which would be our main option besides flat vertical, which should be the default right now, but actually it isn't. For a terrain, typically flat vertical is going to work the best. I'll go ahead and change that. And if you take a look at the side, we see a lot of stretching, but we're probably not going to notice that on the terrain itself, depending on how steep the slopes are. If we have extremely steep slopes, then that might be something that needs to be changed. So we'll go back to the automatic mode just for right now while we're looking at the surface and working on it. And then once we render it out, we can take a look and figure out exactly which ones really need to be set in order for it to look correct. And the interpolation type can also be very important, but it really depends on the size of the texture you're working with. These textures are very high resolution. They approximately about 8 megapixels per texture. So typically interpolation type is not needed, and we can usually set it to just none. But if you're working with smaller resolution maps, or even with this map, if you're going to be zooming into it really close, you're going to need to choose one of these different types of interpolation methods in order to remove some of the pixelation that is available or that shows up when you render. Because once we get really close to the image, we're going to start to see pixels, but with interpolation type on, what it'll do is blend our pixels in these three different manners, where we have a bilinear, a normalized, and a bicubic method. And each one of these will blend together your pixels in different ways. And if you're familiar with other image mapping programs or interpolation types, then this should be really straightforward for you. But we'll take a look at rendering these very close up right after we go through this so that you can see each one of the different methods because it really is the best way to explain them, because the way they're actually set up and what they actually do can be a little bit difficult to actually explain and understand unless you see it. So now we have just these two texture maps being blended together, just a basic ratio. We could always change the mapping mode of this, the combination mode, to get some different types of effects. And you can see that minimum value looks really neat. We can go back and forth between our materials. We can go to multiply. I'm going to change this back to blend, and let's just take a look at this on our surface right now and what it's going to look like just without any of the other settings and just with these two maps connected to each other with the blender. And one thing you may be able to notice is the crispness of the texture isn't quite full, and that's more about the size of the actual texture right now. We might need to adjust the scaling, but overall it looks really good. We could always zoom into that to see a little bit better. But basically, this is just our simple blend. So let's go ahead and change that to have it based on slope, and then we can see these two texture maps blending together a little bit better. So we'll attach our ratio to our slope option, and we can see that nice blend between the two. And we'll go ahead and render that out, and you'll be able to see it a little bit better. Now, because this terrain is a very low resolution, We are getting a lot of artifacts showing up. So I'm going to go and change that resolution so we can see a little bit better. I don't want to use a procedural terrain right now just because uh, the amount of detail that is in a procedural terrain is going to override a lot of what we see in the material itself, and it might be difficult to tell exactly what it is we're working on. But another thing is, it looks like I'm going to need to change the size of these materials just because we can see a lot of definition, very large areas that are typically small parts of the image. So I'm going to go ahead and scale that down. We're going to open up the Advanced Material Editor and go into the function. And since we have our tiling mode set to repeat, it's going to work with just once our current material and texture reaches the end, it's going to repeat itself. And since these are all seamless textures, that's not going to be a problem. But if you're not working with a seamless texture, then you might need to change it to the mirror mode. But even then, you're going to get some undesired results. So typically, you want to work with the seamless textures. And the entire seamless rock collection is seamless. So it works very easily with all of this. You can also see the scaling is not correct for our second mode, where we had 1.2 on the first, but hadn't changed it on the second. Of course, we're going to be modifying this down a little bit more. So I'm going to change our X to 0.4 on the first one. And let's do 0.334 on the Y. And we'll do the same on the other. And we have a lot smaller of a texture now. We'll click OK. And now I want to increase the resolution of this terrain because right now it just kind of looks terrible. And of course, even as we increase the resolution, because when we created it, it was a much smaller resolution, we have all of this pixelation in here. And there's different ways we could take care of it. We could do an overall erode effect. And we could add some of these onto there. But basically, we're still going to see the majority of the pixels. And really, no matter how much we mess with this, we're still going to have those large pixelated areas. So what I'm going to do is just reset and create a new mountain. And now we have a lot of detail. But I also want to modify that filter that we're using to create the altitude distribution, just because I think that's maybe too much of a cutoff. So we can reset that and create mountain again. And that looks a little bit better. And we'll go ahead and zoom in. Since it's not going to be as pixelated now, and render that out and take a look. And if we take a look at these high slope areas, very steep areas of our terrain, we can see those problems I was talking about with the stretching because of the mapping mode that we're using. The rest of the terrain looks really good. We can see very nice looking texture on the tops and then on the sides of all the areas because it isn't as high of a degree. These are almost 90-degree slopes, very close, so we don't see as much of the texture. It doesn't look quite as good. So we can close that out, and let's just modify our mapping mode. And since our first one, this main material, is appearing on the flatter areas, we can actually change that to flat vertical, and it's not going to cause any problems. But the main problem is this other surface that's appearing with steeper areas, and we don't see it so much showing up on the preview, but on the terrain you can really see it, and whether or not that's just because the resolution of the terrain or the way it was generated, it can be difficult to tell. But let's change this mapping mode to faces. And hopefully we don't get any seams that way, because sometimes with faces, the overall scale of which it projects onto the specific object can be a little bit off, and you might not always notice the way it's going to look. But I am going to change our atmosphere a little just by going to the atmosphere editor, because I want to see some shadows. So we'll change the azimuth and just move our sun around. But I don't want it to completely darken in those problematic areas that we were looking at. I'm going to change the pitch. And I'm also going to go more of an ambient, just a little bit, and that way we can see those areas without them being completely black. And we're still using the global ambience mode, but we could always change that to global illumination if we wanted to look a little bit better. And we can see it does look a little bit better. We do notice some of these little fragments showing up from the shadows, and that's a problem caused by the standard terrain. And basically it goes back to the resolution of that terrain. And what I'm going to do is just copy this material so that we don't lose it. Another thing we could do to save that material is just store it in the side. We could save it. I'm just going to click store, and now we have this material saved. And we can always get it back, but still having it copied as a little bit of a backup. So I'm going to delete our terrain, and we're going to work with the standard terrain, but not in the way we would typically work with one. I'm going to paste the material right away just to get it on there. Let's go ahead and scale this up. And now I don't want as much detail as we would typically get. I'm going to double click to open this up. And now of course it says 256 by 256, but that's really just our preview and also our underlying image map that we can use to modify our procedural terrain. I'm going to turn off zero edges so that we don't have that mountainous look. Go to our procedural tab, and we can change that down to 0.5. And actually, because I don't have a bump map set on our material yet, I'm going to leave this actually just with the way it is as a regular procedural terrain, just those default values. But we'll change that to a noise node later, because this is being generated with a fractal node, which means that all the bump is really part of that fractal node, which is not the fractal node we're using for our material, so it can look a little bit different. But what we can do is to go ahead and change that out, and then you'll be able to really define the bumps of the overall terrain with the material rather than with the terrain itself. Or we could copy the function over from our material in order to define the details of our terrain. And we'll just let that finish rendering out. And we can see this looks really good on this procedural terrain, but of course we don't have that definition caused by the material because all of our definition and basically the bump, because we don't have a bump map set, we're seeing everything from the terrain itself. And it looks good if that's what you're going for, but the thing is we really don't see that blend between the different materials because there are so many slope changes and so many variations. So what I want to do is smooth out our terrain, and we're going to be going into the function editor for that, and you can take a look, and we're going to go through some of the things we can do to modify our terrains. But we want a smoother terrain, and we want to define the bump with the actual bump map, and we can always set up displacement mapping for that as well. So we're going to double click on our terrain, and we can open that up.